Hey Algebros! Today we begin a new unit on powers and roots. I'm going to preface this unit by saying that it really goes back to some just cold hard math that may seem a bit abstract with no added context around it, especially in the earlier units when I'm discussing a lot of rules and a lot of different tricks you can pull off. I just ask that you guys, 1, follow along closely, and 2, fit in a lot of practice, and we're going to get a lot of it, and we're going to work with it through IXL as well throughout our class time preparations. For right now, let's start off with powers, not POWs, powers basics. We're going to go through this as slowly as possible without just throwing a million rules at you at once. But in that process, we do kind of need to explain some definitions that might be a bit overwhelming, but do follow along. So here, I want to start off with the most basic of definitions here, that a power is a mathematical expression. I was almost about to route mathematical expression. Is a mathematical expression is not really the word, more so representation. Is a mathematical representation that implies the multiplication of a number by itself a set number of times. So I'll repeat that. A power is a mathematical representation that implies the multiplication of a number by itself a set number of times. And you've probably seen exponents aplenty already. For example, the most common one that you've probably seen is something like, say, x squared. That basically means x times itself, or x times x, and that just happens 2 times. It doesn't just exist with variables, though. It also can exist with proper numbers. For example, if I were to write, say, 2 to the power of 4, that can be written as 2 times 2 times 2 times 2. Notice the pattern between this 4 over here and the number of 2's that we see over here. These are 4 2's. So this number here is always the number of times we see the base number, while the number that's on the bottom, the not tiny one in this case, is always the number we are multiplying and we could go on forever with plenty of examples about this. For instance, if we had, say, 10 cubed, that's just 10 times 10 times 10, 10 multiplied by itself, we usually represent this by saying that it's multiplied by itself 3 times. Even though technically we only have 2 multiplication signs, we technically denote it this way because there are 3 10s. Might be easier to write it that way. So 3 10s. Similarly, if we were to write 3 to the power of 6, it'd be 3 times 3 times 3 times 3 times 3 times 3 for a total of 6 3's. What's important about this unit is not necessarily finding what this multiplication of 3's ends up being. I don't even know what it is off the top of my head. All I know is that it's 27 times 27, and I'm not doing that right now. What matters here is just the representation of all of this and being able to work with exponents. So for instance, let's see the anatomy of a power. Anatomy. Okay, I can spell. So by definition, the entire thing here, if I were to say a to the power of b, the entire thing is the power. And the way we represent it is going to be a times a times a so on and so forth, times a. So that way, in this way, it is in such a way that a occurs b number of times. And that b over here has a special name. It is called the exponent, while the a is also given a name. This is called the base. So if I ever say the base of a power, I'm referring to the big number. While if I ever refer to the exponent, I'm referring to the small number. A common mistake is to refer to the entire thing as the exponent when it's not actually. All right? So real quick, just to test our knowledge of the anatomy, let's do a couple of eggs. 2 to the 4 and 3 to the 6, let's do. In these two cases, 2 is the either base or the exponent, and 4 is the other one. So let's look at this. 2, is that the big number or the small number? Well, it's the big number with the little number raised up above it. So in this case, 2 is the base, while 4 is the exponent, because it's the tiny number that is raised up. And this is the big guy. Let me make that a much clearer way of writing guy. Now, for 3 to the 6, let me ask it a little bit differently. Which is the base? Which is the exponent? Well, in this case, the base is always going to be the big number. In that case, here it is 3. Well, the small number here is nothing more than the 6. I have a quick note to make before we go any further, and that's with the reading of powers. So, how to read these. So if you had something like 2 to the 4, this can be read as either 2 to the 4th power or 2 exponent form. This is important to write, and I do want you guys to write these down just so that way you know how we read these things going forward. Next, with a 2 as your exponent, things get a little bit different because we do have an alternative representation here, or like not representation, but rather reading of it, and we're going to use it frequently. For example, here we could mimic what we've done previously by saying 3 to the 2nd power, 3 to the 2nd power, or mimicking the second one, 3 exponent 2. Three exponent 2. In this case, now we have one more, because 2 as our exponent is a nice little exception. Or we can say 3 squared. This is something we've seen before, because anytime we've seen something like x with that exponent, we always read it as x squared. So this might already be familiar to some of you. Similarly, we have one other exception to the rule, and that's if we ever have an exponent 3. So again, same deal as before. We can have 10 exponent 3. Or 10 to the 3rd power. Or one more example here. We can say what we call 10 cubed. And before you ask, to my knowledge, there is no shortcut for 4 or for 5. These are the only ones you're responsible for, and quite frankly, they're the only ones I know off the top of my head. Now, before I move on from the basics, I do have a couple of special cases. Ones that we're going to run into quite a bit. For instance, if a number, any number in this case, has no exponent, then it has an unwritten exponent. It has an unwritten exponent of 1. It's kind of like fractions. Whenever you see a whole number with no denominator, the denominator is implied to be 1. So it's like denominators of 1. 1 is always the default, so we don't always have to show it. So if you ever had a number like, say, 4 to the power of 1, it can just be written as 4, and vice versa. It's also similar to a denominator of 1, or actually, a coefficient of 1. That's another case where we don't have to write 1. 1 is a special case. Sometimes it likes to hide in the shadows, but you always know it's there with those little hints, like no denominator, no coefficient, or now, the next example, no exponent. Next, the second, and I think this is the last one that I'm going to have to show you guys. This one is the case of when we have an exponent 0. Any number raised to exponent 0 equals, once again, we come back with our old buddy, 1. So what this means is, no matter what number you have in your base, if we have an exponent of 0, the entire thing is just going to equal 1. So for example, 4 exponent 0 is 1. X to the power of 0, also 1. 1 plus y, all to the power of 0, not x, sorry, power of 0, just 1. I like to show a little bit of an example of y. Let me show you some very basic examples right here. For example, if I had 2 to the power 1, we know that's just 2. 2 to the power of 2 is 2 times 2. 2 to the power of 3 is 2 times 2 times 2, not 3, times 2. All right? So if we're wondering what 2 to the power of 0 is, I'm going to leave this blank for right now. But one thing we can note about all of this is that, remember, 1 is the neutral element in multiplication. So I could kind of here, and not changing the outcome, write times 1 for each case. Let me be consistent with my multiplication. Times 1, times 1, times 1. And as you can see up here with the 0, there is nothing, so I have to leave just 1. So the implication here is that there are no 2's, just the 1. That is probably the nicest way that I can show at the surface level of algebra why anything to the power of 0 is 1. Just instead of 2, think of it with any other base. All right? So that was a lot of the basics that we're going to cover. There are a couple of tricks that I want to show you guys, but I'll show them to you in the next video. For right now, take solace in the fact that there is no you try this time. And I'll see you next time when we talk about power tricks.